Good now. Camera is not proper actually. Okay, are we all settled? Okay, so today's class, what we are going to study is called as Hadoop ecosystem. Very critical part of the Hadoop distributed file system. As part of your assignment one, you have installed Hadoop, right? So Hadoop itself doesn't work in standalone. Okay, it includes many packages which are integrated to the Hadoop core system. Okay, we will study about Hadoop core system and we'll understand two basic concepts: how Hadoop writes and how Hadoop reads from the distributed file system. Clear? Very important topic. You will be hearing a lot of softwares which are used with integration with the core Hadoop system. Important thing is you need to know and understand where which component is used. Okay. As part of your course, we will not cover every components of the Hadoop. Very common ones we will cover it. Okay. You may or you may not need all the integration component knowledge in order to work on it. Okay, depending upon the case to case study in your organization, you will be using it. But I will give you the background where and how those are used. Okay. I hope I'm recording, right? So the content is taken from these sources. Again, you want to go through these sources, you are good to go. But if you don't want to go through, I will go into the details of the content. Okay. So this is history of Hadoop ecosystem. Hadoop is a technology to share massive data set in a cluster of a cheap machines in distributed manner. Last time, did I explain you about commodity hardware? You all remember what do you mean by commodity hardware? No? So basically, you all have not gone through the Zoom recording. Okay, so Hadoop commodity hardware is the slave machines. Okay, the master machines are powerful machines, and the slave machines which only do the processing is called as commodity hardware. Why we call it commodity hardware? Because they are hosted in a low capacity, low infrastructure machines. They can be physical machine, they can be virtual machine, they can be machines on a cloud. Okay. How many of you remember? Before I go forward with the next topic, tell me yes or no. You don't remember? You remember? So I will go through it and then just have a brief understanding of last class if you have not able to go through it. So Hadoop is a de facto industry standard platform solution for big data technology due to unfriendly user interface. Till now you have seen, you have installed Hadoop, right? How do you run it? You run it through command prompt, right? Yes. As well as when you run it in a Unix environment or Ubuntu environment, every place Hadoop in a core sense has to be executed through command prompt, which is not good from the user perspective. Like you and me, if we want to learn something, we would like an application to be more user friendly, right? People don't want to run a Unix shell script because you have to write a lot, right? Rather, you will try to run it in a Linux environment where you can run it through easier options. Okay. These ecosystem components are different services deployed on various enterprises. So when I will talk about Hadoop ecosystem, basically it means an integration of all the application which can be hooked up. It's like a hub. Okay, you have a core system and every application can plug and play with that core system. Okay, that's an integration of Hadoop ecosystem. Each Hadoop ecosystem component is developed to deliver explicit function, and each has its own developer community and individual release cycle. Okay, so every integration which gets integrated to Hadoop ecosystem has a developer community and has a support community to support that form of features. Officially, Hadoop ecosystem has 15 components, but it is progressing and expanding. Depending upon the business use case, they are developing newer and newer integration software that can hook up with the Hadoop ecosystem. I'm not going to the history of evolution. You all can read it. Okay, that's not important. Okay, this is Hadoop ecosystem. Let me go through a little bit behind the previous class. I feel like you have not gone through it. Please read it. If you don't read it, there is no point of learning it. It's a very good learning because the technology is moving in the direction. Okay, so you should start reading it a lot. Okay, so Hadoop ecosystem is, before going to Hadoop ecosystem, last time I told you there is something called as MapReduce, right? Did we discuss about it? What does MapReduce do? MapReduce will actually break up a big problem into a smaller problem. Smaller problem will be broken down into key value pair. Key value pair will be sorted, shuffled, and merged together in order to process the solution faster. MapReduce concept deals with something called as divide and conquer concept. Divide and conquer means, guys, you three all can come this side here. Unnecessary why you were sitting here. So divide and conquer means you are breaking a big data set into smaller chunks so that when the smaller chunks are sent to the slave machine, they can be processed faster, right? Three concepts are used in Hadoop. Number one is called as divide and conquer. Okay. Number two process is called as parallel processing. Why I told you it is a parallel processing? Let's say this is your master server, which is called as name node. Did we discuss this? I think a lot of people were not there, right? Last class. You missed the critical part of it. Please read the video. Okay. Please go through it again. Otherwise, you will not understand anything I am going to say after fourth class. It will be completely blank. It's not a very basic English study. Okay. It's a difficult concept. If you understand it, it is good for you. Okay. So you had when you install your assignment one, you did a name node and then you did a data node, right? Since it is installed on your local machine, it's one name node and one data node. Okay. When you deal with the enterprise thing, I can have multiple data node connected to one name node. Understood? These machines which are data node are called a slave machine. In some software, it is called a slave machine. This is called as master. Some places you call it name node and data node. Other software you call it as an aggregator, master aggregator and child aggregator or leaf node. Different software use different naming convention. End of the day, concept is still the same. You have one master, you have multiple data node. You can have, in order to increase reliability, you can have one more name node, which is load balancer. Okay, just to add a reliability, if one fails, other one can cover for it. Yes.
The data nodes are the number of applications?
No, data nodes are the space where the data will be stored. Okay, so Hadoop distributed file system means if you have this big size. Okay, let me give an example. I think you people missed the previous class. I will try to explain you again. Think in this way. I have got 10 gigabyte of a notepad file. Okay, understood? If I open on your local machine in Notepad++, let's assume it opens up. Okay, 10 gigabit may have 100 million lines of code. Okay, simple notepad. Now, if I ask you to search my name, Harish, you will do Control F and search, right? And let's say my name is appearing 5,000 times. How long this will take to happen? It will take maybe hours, or your machine will crash or something like that. That will happen. Why? Because it is searching line by line, right? It is searching line by line in your notepad, right? Sequence of operation is sequential. You have one instance of file running on one machine, and that machine has been read from top to bottom, right? This machine folder file which is open on your main memory, right? It's open in your RAM because it is being pulled from the disk and open in your RAM. Now you're viewing that report. The problem of this big data is solved by the concept of divide and conquer. Divide and conquer means what I'm doing. I'm taking 10 gigabits of same file. If I break it into 10 different equal blocks, how much each will be? 1 gigabyte, right? Same file which I have, I will split into 10 different parts of 1 gigabyte. Assume that it is equal, okay? Now I give this 1 gigabit file to 10 different people, right? And then I will ask this 10 people, can you search my name? how much work you all have to do if it is 10 people? You have to search in 1 gigabit file only, right? Resource requirement is low. Processing capability is fast, right? And third is parallel processing, because you all will be doing the same task which I have given it to you, right? Once you find the result, what are you going to do? You are going to send it back to me saying that this is the number of times I found your name, right? I will take all of your name, club it together and form one master list that this is my data where my name is found. This entire process is called as map reduce process, which I explained to you last time. What are we doing? Whenever you open a file, every word, like word count problem, right? What are you doing? You have one file, right? What did I told you as part of your assignment? Upload in an HDFS file system. What I am telling you to do? I am telling you to do, take a notepad file, whichever guys you all have done the assignment. You have taken a word file, right? And I asked you to use a put statement, right? Put source path and destination path. What were you trying to do? You're taking a file from your local hard drive, C drive, my document, F drive, wherever it is, right? I'm asking to take that file and put it in a Hadoop distributed file system, which is called a HDFS. This is not the file system of your C or D or F drive. It's a dedicated file system, which is managing your files. Okay. It's not your, so if you save something on your C or D drive, it gets stored into which format? Windows file format is what? This format is what? No, NTFS, new technology file system, right? Before it was file allocation table, FAT. In Unix, you have a different file system. File system basically means how the data is stored on your disk. Hadoop file system says, I'm not going to store your data into form of a regular NTFS format. I'm going to store a data into my format, which is Hadoop distributed file system. What does it mean? It means the data which you are putting into Hadoop file system, you are going to put it in your data node. When you do the put statement, right? If you see the assignment, you will see that there is a place where I have written HDFS file, HDFS minus DFS minus put C:\\. I given the path where my source file is there, space the destination path slash folder name. That folder path is not your C or D or F drive. It's a HDFS file system path where I would like to store the data. When you created a install your Hadoop, what did you do? You created one name node and one data node. Since you have only one data node that is stored in one partition of HDFS, right? Because you don't have 5-6 cluster machine, right? You are doing in your class. So you have one data node folder and one name node. In enterprise, we may have hundreds of data nodes, right? So it can be stored anywhere. Now, how the storage happens in Hadoop is when you upload that file, it doesn't get stored like one chunk, as in your case of Windows, right? When you save the file, what happened? One file is stored, right? In Hadoop, what happened? That same file gets broken down into smaller part. You don't see it, but Hadoop, what it does it when you do a put command, it uploads the file, and based on the configuration, it will split the file and store into different data nodes, right? When you split the data nodes into different part, let's say that 1 gig file, 1 gigabit is stored here. Again, I'm just roughly doing it. Doesn't mean that it has to be 1 gigabyte. Okay. The split goes with certain concept, okay, which we call it as partitioning. That is done by architect. We all sit together and understand that how the data should be split in what configuration, 128 MB, 256 MB, 512, there are different configuration. So for simplicity, let's say 1 gigabyte file is split into 3 segments of data node, right? Let's assume that from line number 1 to line 100 is stored here. 101 till 501 is stored here. 502 to 1002 is stored here. Split of the file, right? Now the file is how it is stored. It is stored in a form of a distributed data. It's not at one place, right? Since in your lab assignment, you have only one data node, that's why you don't see that. Logically, when you run the map reduce jar program, you will see that it gives an output with the partition details. Read that log that will show you the partition. Internally, how does that is being performed? is done by Hadoop. You don't have to worry about it. Okay, now the data is split into 3 of the data nodes. Okay, now for example, in the assignment 1, I told you to do a word count, right? Word count through a map reduce program. I told you not to write a Python. I told you to use jar, which is already provided in the Python, in the Hadoop folder, right? It's an inbuilt feature that is pushed inside the Hadoop ecosystem. I will explain you this, okay? What it is basically doing, what it is doing is, when you run that command, this name node is a master node, okay? When the request goes to this name node, what does name node do? Name node assign the task to all the data node. What to do? Find the word count. Okay, how does it do? Let's take one example. So same request is sent. It's like a teacher telling a student to do the same work to all the student. Okay, so master sends a request to one of the or all of the data node in parallel. Take an example on this data node. What's happening when the request is sent to this data node, right? The file is opened. File is opened because it's split, right? The file section is opened. Now each and every sentence in the file, let's say I have written, I am student of Seneca, right? This is the first line. Okay, you may have like hundreds of lines. The first step, what it does is the program sends a request. The jar will actually read the words inside it. Okay, when it reads the word inside it, what is this first word? Right, the first word is taken and it's associated with key value pair. Basically, what it does, it takes each word, right? Take each words and put a value. Value will always and always be 1. Okay, so let's say I am student of Seneca, and let's say I put a next sentence in continuation from, just let me put from Canada, something like this. Okay, and the continuation sentence is again, I am from. So if you see this I is repeated here, right? In a sentence that can happen, right? So the first word is assigned with key value pair, second word is assigned with key value pair, third is assigned with key value pair. Every word is assigned with a key. Key is nothing but your word, and value is assigned as 1. Okay, once that has been achieved, the next step of this, first step, when you assign the key value, it's called as map process. Mapping means you put a key value for every word which has been searched or which have been found in the file. The second step is reduce. Reduce happen in 3-4 stages. The first stage is whenever key value is found, you sort it out. Sort it out means if I is found in this data node, I is found in this data node, I is found in this data node, club together I is in one data node. If M is found in multiple data node, club all the ones which are of same type into a single group. Once you group together, the third step is called as shuffle. Shuffle will do us, shuffle and sort will do the same thing, like finding the value, bringing all in the same data into same group. Once the group is found, what we will do, we'll find how many times that has occurred. If I has occurred 5 times, we'll write I key with value as 5 because it has happened 5 times, right? A word, let's say my name is appearing 500 times in different data nodes. Every place there was one instance matched. I grouped it together and now I'm counting it how many times it has happened. Once it is captured, how many times that happened, every information is sent to name node now. The name node becomes a aggregator, means clubbing all the information into one source folder or one source file where all the history is written. We call it as a dictionary. Right? Now, next time, whenever someone wants to search, I don't have to search in every place, right? My information is already with the name node. Now I can pick it up from any place. Since the process is split into 5 different places, the concept is called as parallel processing. If I have hundreds of machines, I can make the process very fast, right? I told you these machines are called commodity machine because if we are using it in a pay-as-you-go model, like if you have reserved a machine on a cloud, you don't need, till the point you don't need map reduce process, why will you need a machine? right? You don't need it. Whenever you need to process it, just commission it, process it, and then release it, right? So it will reduce your cost. Second is all these data node machines need not be a complete desktop. It can just be a processor. What do you need here? A disk, RAM, and a CPU. Do you need a monitor? No. You can have clusters of machines pointed to a name node or a master node to process it efficiently. Is this clear? So that was the concept from the last class, which you people have not studied. Very good. Okay. So Hadoop ecosystem includes many components. These components are different services deployed on various enterprise. We can integrate these to work variety of data. Each of the Hadoop ecosystem component is developed to deliver explicit functions, and each of its own developer community and individual release cycle. Whenever you install Hadoop, this three will always be there. You will have HDFS file system because you have to upload the file. You all have done the put statement, right? Put and get. Put means putting the data into the Hadoop file system. Get means to retrieve the data from the file system. Yarn process will always be there as per the latest version of Hadoop. I think after 2 point some version, Yarn is called as yet another resource negotiator. I will explain you what does Yarn means in week 4 or 5. Basically, the job of Yarn is to monitor and ensure the management of resources. Do you understand what do you mean? What I'm saying? Yarn's task is to manage the resources. Resource manager. Think about there are 10 people, and I have given an assignment to all the 10 people. Out of the 10 people, 8 have already 8 are doing it, 2 have done and got freed up. So I can assign them more tasks, right? So the task assignment and the resource monitoring is done by Yarn process. It's a process that runs over Hadoop system. Okay. Third is the core part of it is called as MapReduce, which is actually doing this data processing. Okay. So as part of your assignment, you are only going to do the word count problem. Okay. When you go an enterprise, again, I'm saying you may not or you will never be doing word count problem. Right? It's an assignment given to you as a sample. In the organization, how the program will be given to you is how to get the split of the data for searching a specific keyword. Okay. Identifying particular set of data and appearance of that data in the iteration or number of time it has happened. You don't have to write a MapReduce program. You have to use the library of MapReduce program to extract the value which you need. Do you understand? You don't have to write a program to find a word count. Word count is just a sample example. In the organization, what will happen is you will have a huge file coming from a source system, and those source system will actually dump the data on the name node, and name node will split the data and put it into different file system. Right? Your data is stored in different file system across the cluster. Right? Now the question your organization will ask, okay, now data is split up. I want to find this data, how many times it is appearing. Or it may be asked, I need to find a correlation of this data being appearing again and again. Again, there may be hundreds and thousands of use cases. What you have to do, you have to use this MapReduce jar to execute it. Okay. As part of the next assignment, I will tell you how to write the Python script to run it. But in a reality, you are not going to write it in your organization. You have to use the logic, what has to be extracted and what needs to be output as part of the MapReduce program. Okay, you have to use that feature. Okay, so this 3 is the core or heart of the Hadoop system. MapReduce is used for making distributed parallel algorithm. MapReduce make it possible to carry out processing logic. Now, whatever you see across this, right, outside this is a Hadoop ecosystem. Okay, so we will go from here. Okay, table and schema management is an integration or an add-on product of Hadoop. You can install over it. When I say install over it, basically you have to just install the jar. Okay, it takes 10 minutes, less than 5 minutes to do it. Okay, the other component is called as pig and hive. Pig scripting and a hive SQL query. These are used for querying the data from the database. Okay, it's like a SQL editor. Type a query and you can extract the data. Again, when I'm saying SQL, there are concepts which are different from the regular SQL. Why? The classical example in the regular SQL, you have auto increment. Everyone know? Whenever you create a table and you insert, every data is stored line by line as a part of primary key, right? And it auto increments by 1. In this case, how would you auto increment when your data is split into 3, 4, 5, 10 different segments? And you don't know where it is going to get stored, right? Am I clear, right? So the auto increment concept never works on big data. So if you type a auto increment in Hive, you will get an error that it doesn't understand. How data is stored is, data is stored in form of a similar to like a pointer concept, location address. Okay. Hive, pig developed by Yahoo, which works on a pig Latin language, which is a query-based language similar to SQL. Hive performs reading and writing of large set of data. However, its query language is called as Hive query language. Again, if you know how to write a SQL statement, it will be very easy for you to understand how to write SQL statement. Okay. It's no rocket science. Okay. The same syntax, similar to that syntax are used. Okay. Mahout allows machine learnability to a system or application. If you see here, there is one of the component called as Apache Drill interactive analysis and machine learning. It uses the concept of Mahout. Okay, the concept of machine learning comes here using that particular package. Okay, so whenever you have Hadoop installed on your machine, you can install any number of packages over it. There are hundreds of them. I should not say 100, there are more than 20, I remember. I don't know about 100, but yeah, sorry for that, but it is more than 20. I don't remember all the names, but very commonly these are used. There is one of them which is called as Avro. Avro, anyone know? Avro is a schema of JSON. Okay. So when you test the API, right? You have REST API and SOAP UI, SOAP API, right? Yes or no, guys?
Yes.
Have you seen SOAP?
Yeah.
No. How many of you have seen or how many of you have not seen? Sorry? What is SOAP? SOAP? What is SOAP? It's not like a soap, washing soap, right?
That's simple object access protocol, Prof.
Have you heard about this word?
Yes. API,
What does it stand for?
API principle.
Yes, that I know abbreviation. After that, how does it look like? Huh? It's like an XML. So it will have something like this. You will have all this XML binding together with something like this, with a schema name and all those things, right? Inside it. So this whole file is stored into something called as WSDL, which stands for what? Web Service Definition Language. Okay, so when you are creating an API and you want all the operations supported by API, for example, let's say I have an API to be developed. In that API, I should search a customer, edit a customer, save the customer, delete the customer. All the operation, if I have to write in a single package, right? So I will write SOAP. Okay, because my all the operations are written inside a single WSDL, I will take that WSDL and deploy it in the web server. Whichever operation you want to use from the UI, you hit the front end, the API function will be called and retrieved and responded. Okay, what is the problem with the SOAP? Anyone? First of all, it's an old methodology, right? Second is, with the increase in the functionality added within the application, this SOAP file will go on increasing, right? So let's say today there are 20 functions supported by your API. Tomorrow it is 25, then 50, then 100, 200. How much you will extend this SOAP? The management becomes difficult, right? To update and edit and update and deploy. The problem with the SOAP is that it is difficult to manage, right? And it doesn't work as efficiently as REST. The other service is called as REST services. What is REST services? REST services are having API with an endpoint, that is URL will be given to you. with a question mark, and then you will have a query parameter here. So methods are like get, put, post, delete, update, and what else? Attach, right? 1, 2, 3, 4, 5, 6, something like 6, 7, right? What does this do? In case of REST API, which is called as restless something, I don't remember the full form. So that service API, each and every endpoint can hold one operation, right? You can have a get method of multiple type with all the operation. Let's say get customer information, get his account number, get his SIN number, get his postal code. What are you trying to do? You have one of endpoints and you can put the query parameters to search what you want, right? Easy to deploy, faster to execute, well, easy to manage, good for plug and play. You want to add hundreds of API, go on writing APIs. That's why you will see API development is very easy, right? Nowadays, everyone develops API. So what is the advantage? It is faster, easier. It can be run on distributed environment, easily deployable, quicker to learn and all those stuff, right? The problem with REST and SOAP is not everything is bad here. The best part of this is very secure. It's very high in security. SOAP services are very, very, very secure. REST services are also secure, but depending upon the TLS implementation you have, TLS 1.2, TLS 1.3, there are many security levels on which you can set up your REST and POST. Okay, so what I was explaining. So within API, you have something called as Avro. The third concept of REST API, within REST API, there is a format of response. One format is a regular payload, right? In which you will write something in the payload inside it, right? Okay. So in a regular REST service, you will have endpoint and you have a body parameter, right? In the body, you will write something in the parenthesis name and, but when it is a format of a JSON, Java, what is it?
Object notation.
Object notation, right? What does it? It has got some structure, right? When those structure of a certain format, there is one schema which is called as Avro. It's a schema methodology how to use JSON in a certain schema format. That schema is called as Avro. Okay, we use it in the organization. So again, these are ways how you are going to integrate the processing with the MapReduce. Then you have Apache HBase. It's a NoSQL database which support all kind of data, thus capable of handling anything of Hadoop database. It provides capability of Google Big Table, thus able to work on big data set effectively. It is Apache HBase is used for mostly Google search. Okay. Then you have SQOOP, helps us to load and process data directly into Hive or Hive database. It is basically for loader process, loading the data. Flume is a collecting, aggregating and moving huge amount of streaming data from the external web server to the central store, say HDFS or HBase files. Okay. Again, these are the product. You can think about product getting integrated to the Hadoop core system. Zookeeper, again, you will hear this word quite a lot. Zookeeper, there was a huge issue with the management and coordination of the synchronization among the resources. So this guy, Jan, was supposed to do the entire management of the cluster, entire management of the resource, but it was an overhead process. In order to facilitate this process, we developed something called a zookeeper or a coordinator. It is like a person who manages a zoo. You people see zookeeper, zoo, you understand, right? How do you manage your lions and tigers and all those stuff? So you need a person who can manage this cluster and resources properly. Okay. Then you have Uzi. Uzi is a simply perform the task of scheduler, the scheduling job and binding them together as a single unit. So if you want to run any of the package, any of the loader process or any of the loading of the data in a certain specified time interval, it's act as a scheduler. Scheduler is used for running the loading process in parallel. Okay. Again, one of the classical example of Uzi is we use in our organization called a Stone Branch. It's a product of single store. It's called a Stone Branch, where is a scheduler is there, where you can select which jobs you want to run in parallel, which job you want to run in a sequential format. Then there is something called as Ambari. Ambari is a web-based tool for provisioning, managing, and monitoring Apache Hadoop cluster, which includes support of HDFS Hadoop, Hadoop MapReduce. It's more of a monitoring-based system. Ambari is something like, I want to see how my data clusters are running, how my name nodes are running, what is the utilization on each of the nodes, how is my master node performing, right? If I need to see and monitor all those statistics, how are we going to do it? This is more of a monitoring tool dashboard. Okay, again, different company, if you go, different organization, different product will have different monitoring systems. Okay, some places they use Kubernetes, some places they will use MemSQL, single store monitoring, some places Dynatrace, many tools are there. Okay, so depending upon what component you are going to integrate it as part of your Hadoop ecosystem, you will use that monitoring system. Okay, any questions on this? No question? Any questions before we move to the next slide? No questions. Good. Hadoop is an open source software framework that allows the user to store and process large amount of data. Again, I'm reading it. Pause me if you don't understand, because I would try to cover the topic which is critical after this few slides. Okay. Hadoop was introduced in practice in 2011. Hadoop can operate on a computer cluster, and respectively, it can consider data cluster. Hadoop offers a special organized storage of big data called as Hadoop distributed file system. Okay. Data processing is performed by MapReduce programming model. Correct? Data processing means, how does the data processing happen? Divide and conquer. Split the data. When you split the data into smaller portion, have the data into key value pair, assign a key value to each of the data word. Once it is assigned, then you sort it out, shuffle it, and then aggregate it to the master node to keep the record for extraction. Using Hadoop, MapReduce data processing can be executed on multiple server called as node or slave node or a data node. Okay. Hadoop is designed to operate in a commodity machine. Basically, it is designed to be operated on slave, master slave configuration with the commodity machines as a slave or low powered or low capacity machines. Performance of each single machine is getting less important. I think I missed one more topic. I explained you two things, right? One was parallel, one was divide and conquer, right? Yeah. Right. Second was parallel processing. Right. Yeah. Third is something called as data locality. Did you all remember that? Data locality. You people didn't read the last slide? Anyone who has read it? See, you people have to read it, otherwise it will be very tough to give you the background understanding. Okay. Today I'm trying to cover the previous class also, but please read it. If you really want to get a good job, because this is the future. Okay. You like it or you don't like it, you have to learn it. I'm telling you very honestly, people are hiring more and more people to get an AI related job. And I'm not asking you all to become a data scientist right away or being a senior position. You need to understand data. If you cannot understand the data and how the big data works, every organization is moving away from the standard traditional approach to a big data concept. If you don't know it, you will not be able to understand what language they are speaking. It's not a programming, it's a logic you need to understand. Okay, so data locality works in data processing will happen where the data resides. I'm repeating up again, data locality means processing of the data will happen where the data is actually residing. Okay, think in a traditional approach, what used to happen? Data was collected from different sources. Okay, let's say I have a file coming from A, B, C place. Okay, A is a database, B is a database, C is a database. I brought that file to a single place, right? And then I do the processing. When I'm doing a processing, my host machine where the processing is happening is overloaded, right? Where is file staying? File is staying in A, B, and C, right? So in a traditional approach, in a regular traditional approach, what used to happen? You used to have one server, right? You used to have one server. And how many of you know about network drive? or I'm mapping a network drive C, D, F, G, H, whatever you say, by backslash something like, and give the host name slash C drive and share the path and copy it from there. Okay, let's make it easy. Let's say Mr. A is here, Mr. B is here, Mr. C is here, Mr. D is here. Okay, in a traditional approach, what used to happen was I used to bring the data from different sources to my server. I used to bring the data from different sources to my powerful server, and here the processing used to happen. Why? Because I needed all the data. Right? I needed all the data to get the outcome of the result. I cannot get the result from the partial data. So what was the factor in? I have to bring all the data, copy it on my master server, right? So when you are copying the data from different places, what was happening? What was happening? If you are copying a data from different sources, I/O will happen. What is I/O? Input output operation used to happen, which is a resource intensive activity. You are picking a data from a disk and bringing it to another location. So what are you doing? You are increasing the network traffic, right? Bringing the network traffic, you need a high bandwidth internet connection, right? You need a high power machine to pull the data. You need a destination server to run a parallel job of picking everything and then collating everything together. It's a stressed system, right? So you have to upscale the server to more vertical or horizontal, right? So that with the increase in the volume and the traffic coming to this server, you can manage that resource, right? Right. In this case, where is data residing? Data is residing here, right? Where is processing happening? Server, right? This is a traditional approach. In Hadoop, the concept of data locality works. Concept of data locality means this is the master server or name node, right? This is your data node. All these are data node, right? Where is data stored? All the data node. What is master name node is doing? It is sending the request what to do to all the data nodes. What request is sending? It is sending map reduce process. Okay. Do the map work. Do the reduce work. Where the actual processing is happening? Processing is happening on the commodity hardware or the data node. Is server overloaded? It's like a teacher. Does teacher do an assignment? Teacher will never do the assignment. What is teacher doing? Teacher is assigning an assignment to you. So think about all the data is with you and I'm giving you the assignment to do it and you all are doing it. Once you are doing it, what I'm asking you to give back your results. The job of the name node is what? One, to manage the nodes, right? I need to check how every one of you are doing, right? So I'm coordinating with everyone as a part of a process to see how you all are doing the task which was given to you. Second task is when you have processed it, give me the result. My job is to only collate it and aggregate it, right? Where is processing happening? Processing happening in a data node. Data is stored in the data node. That's why it is called as data locality. Do the processing on the place where the data resides, right? Any question, guys? Oh God. Performance of each single machine getting less important. This is the concept of data locality. Nodes can be grouped into cluster, dispersing, processing, and memory constraint or for the faster access of the data set. Please see it. Any question, please ask it. Because I'm just reading it now, okay? Nodes can be grouped into cluster, dispersing, processing, and memory constraint for faster access to data set. Cluster-based processing also helps to improve scalability and reliability. Cluster, you understand? Cluster means, what is cluster? Group of servers hosted on a specific, I would call it a work zone or a management zone, different company call different names. Okay. So let's say one cluster can be this lab, all the machines sitting here. Another cluster can be other room with all the machines. Okay. Hadoop divides large file into blocks and store them in different cluster nodes, thus making system high fault tolerant. Anyone has any question on this? You should be asking me a question from this. Guys, please.
Uh,
Yes, ask me.
like you said that a data is distributed into different parts and it says highly fault tolerant.
Yes.
Like different data is stored or redundant data is stored.
Exactly. The replication concepts come into picture. When you split the data into different nodes, right? In order to make it fault tolerant, if this, you should be asking me this question, Professor, what will happen if this data node goes down? Right? I have a file here sitting here. Let's say 1 gigabyte. 1 gigabyte is here, 1 gigabyte here, 1 gigabyte here. Let's say this machine goes down. It's like you are 30 students in the class and I've given you all an assignment with a different data, right? I've given you one question set, one, like there are 30 sets of questions, right? I've given to you to all of them. One guy become absent. Where will I get the answer from?
I think the name node will have some like a backup where.
Why will name node keep? Your data locality concept means data cannot be in name node. Data needs to be in the slave nodes, right? Or we call this slave node as a leaf node, right? If this data node goes down, what will happen? I'm not able to get that data, right? That guy is absent. I don't know. He took the assignment. He never came back. What will I do? I cannot aggregate it, right? I have to club together all the result. Otherwise, this data is lost, right? In order to avoid that issue, something called as replication happens. Replication means writing the data at multiple places, writing the same data to multiple places. Example is, if this 1 gigabyte file is there, I will write this 1 gigabyte copy here also, right? So that if this goes down, I will pull it from here. So it's like giving giving an assignment, same assignment to two people at the same time. So that if one is not doing it, I can pick it from the second one and give the instruction to get the outcome of it. Yes.
So they all have the same thing?
No. If you start writing the replication, all of the same thing, then what's the point of a traditional versus new approach? If you start making the replication copy, right?
Like if they are doing a different job, then how actually is it?
It has to do all the same job. Okay. The job given to the data node is same to all. Master will give the same instruction to all the data node.
All of them have the
Same data, right?
Yeah, definitely. So that's why I'm saying, if I am giving, okay, let me explain you in a very simplistic way. I have one file of, let's say a book. A book I have taken of 100 pages and I'm tearing it and giving 10 pages to each of you. All of you have the same data?
No.
No, right? Yes? Who said yes? Why this came down here? What happened to this?
It turned off. I think.
How to turn it on?
The projector
How to turn it on?
go back.
Oops. We'll leave it. You all can see there, right? So if I take a book of 100 pages and break that 100 pages into 10 different group, 1 to 10, 11 to 20 like this, and I give it to 10 people, right? All these 10 people have the same data?
No.
No, all of you have different data. Now, if as a master, if I'm asking, can you find the word, let's say Canada, in all the 10 people? So I send 1, 2, 3, 4. I gave the same instruction to all 10 people, right? The instruction is same. The job operation you have to perform is the same, but the data set is different for you all, right?
Everyone will be able to give the correct one.
The person who has will give me the answer saying that I found 10 times, I found 0 times, I found 2 times, I found 5 times, right? Once that information is collected to me, I will collect together, collate it, and create a file with me that this is the total aggregated data.
But how does the redundancy work?
Yes, I'm coming. So let's say out of that 10 people, 2 people went to home and didn't do the work. I took the pages. What I am supposed to do?
I don't know.
It's lost, right? So what I am going to do is, whenever I am first giving you the data, that file of 10 pages, I make 2 copies of it and give to 2 people at the same time. So that even if one goes away, I can take it from the other person and say that, oh, you do it because this person is not available. Right? Yes, ask me.
So for example, you have three data nodes. They all have different data. Or like.
If there are 3 data nodes and I have to split the file 3 times, I'll make the copy of the same data into 3 places.
So will you have
So
a
they
thing-
all have the same thing then?
You are right, you will have the same thing, but you are thinking from a small perspective. I'm asking you, again, replication has a drawback. You cannot replicate everything in every node, right? Depends on the architect, and this is the question you people supposed to ask me. How would you define the replication? I can have 1 copy at 4 places, I can have 1 copy at 16 places. I have an organization where there is a critical customer trading data. It's a very critical, sensitive data. If I lose a data, I need to make sure that I can recover it. So I have a replication of 16. 16 in 90 machines. Can you imagine? 16 copies of the same data in 90 split into 90 machines. So how many machines can go down? 1, 2, 5, 10, 15, right? But still there is one node where the data will be there, right? Copy of it. And now this 16 replication happening on 90 machines. These machines are not on one country. So let's say North America was flooded. So I have a copy in Europe. So not 16 copies are all kept in North American cloud server. It is kept in North America, Brazil, Japan, Europe. Not everything will go down, right? So if the management zone of Europe is down, I know I can pick up the data from the US cloud servers, right?
So you define the number of replication.
That's why I'm saying replication has an impact on the performance. If you are replicating it, we have to do the verification how the replication is going to affect my resource consumption, because you are trying to tell that, okay, I want to make a copy of it. It is a trade-off between your reliability versus your performance. How, if I cannot make any excuse of losing a data, I will make sure the data is never lost. Whether it is slow by 2 seconds, I'm fine with it. But if the data is not so sensitive, and I know every night I do an archive, again, there are reliability mechanism. Every night we run a batch process which takes all the data and keep a repository in a drive also. So if something may happen, all the 16 may go down, right? To protect that also, we keep a backup also, right? So that we can roll it back, right?
So question, if you have all the nodes, let's say all the nodes are up,
Mhm.
and you send the map reduce operation, will it? So,
No,
okay, so
there is something called as parity bit, which manages the flag of changing of the data. If the data has been changed or modified, it synchronizes it and updates all the data node. Let's say that particular data node came down, right? And the others one have updated the data, a value. When this comes up, the first thing it will do, it will not serve the client request. It will first update itself to synchronize with the remaining data set. Then only it acts as a service. It's like you missed a class. The next class you join, before you join, you prepare yourself to know what has been happening in the previous week. So you come prepared with that and then you start serving the person. Okay. I don't know why this is not working here. Yes.
Mechanisms of these applications and like the synchronization between the data node, how they come as like native features of Hadoop?
You need to be louder. Can you please?
Yeah, so for the mechanism of replications and synchronizations between the data node, are these features like natively in the Hadoop ecosystem as well?
So synchronization is being managed by Yarn and the master node or the name node. It's not managed by data node. Data node job is to just come up. So if we see the leaf node, there are 900 server. If we find any particular node is down, right, we forcefully restart it, right? Or let's say we restart the instance. We say, okay, restart it. Once it restart and reboots it, the Hadoop Yarn process sees, oh, this server has come up again, right? But it has got an old data. So it will take the dictionary information where this data is replicated, copy is there, and try to have that synchronized with them before it starts serving the request. And again, this happens very fast, right? Only the process startup takes time, maybe 2-3 minutes it will take, depending on how much data is there. But once it starts, it synchronizes itself.
No, but
So basically the jam is going to acting as kind of like a conductor in the orchestra, right? Acting as like the jam system, the jam service is going to act as like a conductor of the whole system.
Yarn act as a resource manager and a process, it's a daemon process that runs to manage and see how the resources are performing. If the resource needs restart, it will restart. Again, there are subcategory of the process inside it that does all the process. Again, I don't want to go into too detail, but just you need to understand it's a replication process to add fault tolerance. You cannot have only one and one copy. You can have multiple copies in order to ensure that your data is still available for consumption.
Jan still has to hold some data regarding, for example, like the history of the node and everything. Like that.
Yarn has a process which is called as node manager. Okay, I will go into that week 4 where I will explain you what, or I think in the upcoming slide it's there. There's something called as node manager and data manager. I will explain you what that synchronization, how that helps. There is a process that runs on this name node. As of now, you have just done that exercise, but you don't know what's going behind the scene, right? Cluster-based processing helps to improve scalability and reliability. I don't know why this is not running here. Cluster-based processing also helps to improve scalability and reliability in case of a problem on one cluster, processing can be moved to proceed on another cluster. Okay, Hadoop divide large data blocks into blocks and store them in different cluster nodes, thus making system high fault tolerant. Hadoop can handle very large data set. Data from the input streams are never changed. It's write once
Hi,
model.
Prof. Hi, Prof.
Write once model means once the data is written to Hadoop distributed file system, it's written. It's not like, oh, I will not write it here, I will write it there. It's decided by the Hadoop distributed file system how the data will be split. I will tell you there is one configuration, you can do it on your split, but again, normally it is not done when you do it on your local machines, okay? The write once model that assumes the data never change after it is written simplifies replication thanks to the model and to the independent parallel processing. The data throughput speeds up. Basically, once it is written to Hadoop distributed file system, it is written permanently on the disk. Okay. What does here it means is if you delete it, it will still say no, deleted means gone. What it says here, it is writing once. It's not writing multiple times. Okay, on a same data node. The processing model works on data locality where computational logic is sent to the data to the nearest cluster node, right? I explained you this, right? You will have a processing on the data node where the data resides. Hadoop core is composed of 3 component: Hadoop distributed file system, Hadoop MapReduce, and yet another resource navigator or called as Yarn Hadoop. The concept of master slave architecture is implemented to organize data processing in HDFS file store, data store. Okay, what is saying? Cannot hear you. Why people toggle the custom panel and return to the podium? What is saying? Anyone has an idea what he's saying? Toggle to laptop to on the laptop and then okay, then go to the podium. Return to the podium. Working.
Yeah, it's something with the projector.
I don't know what is it. Anyways, you people can hear me, right? In the Zoom. Can you can hear me?
Yes, bro.
Okay, if you can hear me, then it's fine. You all can go through the videos, okay? Okay. So this is the question that lady was asking, right? You were asking us. So the two layers are present in the Hadoop is called as HDFS layer, responsible for data. If you see the bottom section of that table, right, on the diagram, the HDFS layer, if you see in the bottom section, right? You all can see that, right?
Yeah.
So that layer has got two things. One is called as name node and data node. You all did in your assignment, right? You created two folders. Data node stores the data and name node is the person who is orchestrating or synchronizing or managing the data nodes. Okay. That's a part of Hadoop HDFS file system layer, means the data storage layer process. Okay. Above that, if you see, there is another process which is called as MapReduce layer, right? What is the job of MapReduce layer? The MapReduce layer process in the master node will have two tasks. One is called as task tracker and second is called as job tracker. Okay. Task tracker is the task. It tells you how much completion of the task has been done. It's like an exam. If you're appearing and if you're doing some progress, I can see, right? 10% completed, 20% completed, 50% completed. I need to know how much progress has been made. That can be managed through task tracker, and job tracker tells you whether the job was completed successfully, failed or suspended, or what has happened. Okay. Is it clear? Job tracker tells me whether my job was completed successfully, failed, passed, or whatever, suspended, right? And task tracker is, if I have assigned you a task, I need to monitor how much completion you have done it. Okay. That tells me the progress that has been made. And job tracker tells me that whether the job was completed, yes or no, suspended, failed, passed, right? Name node and data node, when a client connection is received from the master server. See, I'm reading it, same thing I explained you, but I just let me know if you are not able to understand it. Name node is running on the master server, looks into both the local namespace and the master server namespace to find the matching record. So what is the name node storing? Name node is act as a dictionary, which is storing the namespace information of where the data is residing. Data nodes then gets the record and starts storing them. A data block is a record of data. Data node use the data block to store different types of data such as text, image, video, etc. Name node maintains the data node connection with the client based on replication status of the data node. If data node goes down, the client can still communicate to the name node. The client then gets the latest list of data block from the name node and communicates with the data node that has the newest data block. Okay. The meaning of this is, if I am giving you an assignment, right? How should I track it? How I am tracking it? Tell me how I'm tracking it.
Node manager.
I have a node manager process running with me, which I can see that who all are done doing the assignment, right? In the blackboard. I have a list of all the people, names, and assignment task. If you do it completed, it shows me that submission has happened. If you don't do it, it shows not completed, right? Same process is worked here. Okay. The name node namespace act as a dictionary which stores the information, because now the file has been split and kept in different places, right? It's kept in different places. Who needs to track it? Someone has to track it. So the name node needs to track it. What should he track it? He should track which data node, which sector, which file system, where, which cluster. All this information is stored in the name node. Why? Because if some request comes to search it, he can provide the information where to go and search for it. Right? Because this data is split now, right? Now, if the data is split, how will a person find the data? If some requests come to the name node, where will name node tell that, okay, go here and get the data? That information need to be stored, right? Once the file split has happened or data has been splitted, all the information of the split file, like where it is stored, which data node, which cluster, which address, which location, what is the partition size, and all this block information is stored in the name node, act as a dictionary. Right? It acts as a data dictionary. Right? So the information is stored here so that anyone who comes, this act as a dictionary. It's like someone coming to your college, and in the front desk, what you have? Help desk, right? If you ask them, okay, where should I find room number 405? How will he tell you? Oh, go in this side and you will find this room. Okay, go to the 4th floor, turn right, and all those information. Who stores it? This name node act as a data dictionary in a similar way, storing all the information of the data location and data information, right? So that any new request come, it can give you the direction to pull and extract that data. Clear? Okay. This I have already explained you. One important thing is there is a line written as block size, which is minimum amount of data that can be read or write. Files in HDFS are broken into block size chunks, which are stored in independent unit. The default size of block in HDFS is 128 or 256 MB. Again, when we break down the data into smaller chunks or a block, right? The default size in the configuration is 256. Again, it's not mandatory. Depending upon the file type, depending on the file data, you can change that value. You need a bigger block size, you can make bigger block size. You want smaller block size, you can have it a smaller block size of the split data. The file associated with the metadata are F file system image. Okay, so this is important. The data dictionary concept which I am telling you is called as FS image. Okay, what is this FS image? It's file system image, a persistent checkpoint of file system metadata. Data within data is called as metadata. Basically, data having more than information of just a data is called as metadata. Okay, for example, if I have, yes.
I know you explained, but just want to clarify, you said the new the server is, they not act as a server, right?
Okay, yeah, go ahead, I'm listening.
No, I'm just listening. You said the, they not act as the server, right?
Name node act as a master server, yes.
Yeah, okay.
So let me draw it and try to explain you this one. So this is your name node, okay? Okay, I'm just drawing two data node, okay? Data node, and this is another data node, okay? Now your file has arrived, a huge file. Let's say I take a 1 gigabit file. You split into two parts, okay? For now, we are not doing replication, okay? Just assume it is simplicity. I have one file data here and one split is here, right? Now the data is stored here, the remaining data is stored here, right? This data node will have what information? This data node will have its IP address. This is a slave machine, right? It will have IP address, right? It will have the SDFS file system path where it is stored. What will it have? It will have a partition block, like, okay, it has 128 MB chunks of 4. 1, 2, 3, 4 blocks of 128. Similar to that, it will have 128, 4 blocks, right? Both have separate data set now. Now, let's say it stored it. The SDFS, you, as per the first assignment, you dumped it. The data is stored in SDFS. Now somebody comes and read it. I want to read some line number, not line number, a word XYZ. Right? This request comes here. How will this person say go here and search or go here and search?
Yeah, it's the same.
Hmm?
You can search for the,
Why it will do unnecessary work of searching the same thing in two places?
no, he's gonna do the same instructions for both the nodes.
How? Same instruction can be given, understood, right? But there is an unwanted thing, right? You can do it if your replication is there, if your data of replication is there, if you want to search a same set of instruction, assuming that you're not searching the same, right? Your data block is broken down into different portions, right? I want to find XYZ. Where should I find? Should I find it here or should I find it here? Where should I find? If I find XYZ and XYZ is not here, but it's here, it's a waste of effort, right? Even if I give the same instruction to this is unwanted search, right?
How name node knows the information?
How the name node knows the information? It's through here. There is something called as data dictionary, which is FSIMAG, the word which I said, file system image. What does it stores? A persistent checkpoint of file system metadata. It's a persistent information where, how, when, which location, what's an IP address, which block, which specific sector the data is stored. It's like a pointer information. It's an address information which is stored, not specifically address, it's more than address. It's having not only one information, it has got many information stored against the data which is to be searched, right? We are not talking your data to be stored on your single laptop. It's stored in hundreds of machines, right? Someone has to coordinate and maintain that dictionary, right?
Like an indexing for the,
It's like an indexing, correct. It's like an indexing, but more than an index. Index just stores an address where the place is, information to be searched, right? With the index value. Here I'm storing more than that information. When I'm storing more than that information, that data is called as a metadata. It will store the file system, it will store the data type, it will store a lot of information. Right? It will also store the fragmentation of the data. If the data is half year, it will tell you, okay, till this I will pick it up, remaining will be found here.
From the name node alone, it can figure out which data node has what.
Correct. Because when you are storing it, splitting it, at that time only when the storing happens, it collects all the information. Okay. So one is called as FSIMAGE, is called as persistent checkpoint of file system metadata. Persistent means something that cannot be changed. Persistent means not changed. Persistent means something which cannot be destroyed. Right? It can be changed. Okay. Then what happens if, let's say tomorrow the data location has changed, cluster has changed. So there is something called as edit log. It contains all the recent modification made to the file system with respect to the most recent FSL image. It is like a secretary to the name node. Edit log is like a secretary to the name node. What it does it, any change that is happening on the FSL image, all that change, edit log information is stored in the second file called as edit logs. Okay, it may be residing on the master node. It may be residing on any other location also. Okay, it does not mean that it has to be in the name node. It can be in the name node, but for reliability purpose, we keep it in another place. Why this is important? Edit logs. Why it is important? Why it is important? The question is FS image, right? That holds the persistent data of the information where your data is stored. It's like a dictionary, all the information is stored. It's like an encyclopedia which gives all the information where you can get the data from. I'm saying you can edit it also. So let's say today the data is sitting there, but tomorrow you move the data to other position, you will edit that file, and now this is your FSL image. That edit has happened. Someone will write that edit log. So there is another process which writes the edit log, which whatever changes have been done on FSL image file, there is an edit log file created on other server or maybe on the same server, depending on the configuration and setup. Why it is done?
Because in case you make a mistake.
Exactly.
you can
In
always
case
go back to
somebody
it.
made a mistake, or I have to track it, who made the changes, how it was made. If I have to roll back to the initial stage, I can read the log and revert to the previous configuration. Exactly the same thing the edit logs does. Clear? Good. Data node, secondary name data node is the backup node, which I already told you is acting as a replication mechanism. Okay?
Excuse me.
Yes.
In this concept where it contains an encyclopedia in FSI image, can you give an example like so it stores like address of the data or like?
Again, I can write it, but again, it varies with the application to application. So let's say the data is stored here. So I will have IP address, cluster information. Right? Cluster means whether it is in Guelph cluster or Toronto cluster, whichever cluster. Rack information. Rack, you understand, right? Where you keep the books. So your rack information, then it will tell you which partition information, which drive, which network.
Like I'm asking, how will it identify that this is this data? Like how does it correlate?
When the data is stored, it's stored in a block, right? 128. So it has a starting address and the ending address. If your data is residing between that address, then only it will pick it from that location. So again, you will end of the day not be doing this because nobody will allow you to do this. Okay, it's a very sensitive thing to make changes, but you need to understand the concept. If you can't understand the concept, then you cannot understand that most of the big data concept is retrieval. Very rarely you will be asked to write the data in the Hadoop file system. When you are writing it, basically you are making persistent storage of the information, right? If you go in the big data machine learning concept, you are extracting the data and analyzing it. Okay. Data locality concept I already explained you, right? I'm not reading this, okay? Clusters. Hadoop clusters are built on concept of Hadoop network topology. Important is the concept of computer system commodity, which assume a possibility to utilize any computer as long as it incorporates by Hadoop resource management system or YAN It's a Java-based software framework and parallel processing engine. It enables big data analytic processing tasks to be broken down into smaller tasks that can be performed in parallel by using the algorithm. Configuration of cluster is critically important from the perspective of HDFS performance. Apache daemon need to support nodes may run on the same machine or a different machine subject to the configuration of cluster. Cluster, do you need me to explain what is cluster?
Yes, please.
Okay. Cluster is this. You see on the left and right hand side? How many of you seen a data center? People have seen data center?
Yeah.
Think about, you have seen the books, rack books? Yes, you have a data center of your school here, right? So if you keep lot of processors or the CPU rack by rack in a single rack, then it becomes one network cluster, right? If you have seen the library, how library aisles are kept, right? Your books are there. Think about books are nothing but as processors. CPU with a memory and a RAM. So you put like that all in a single aisle, then it is a single rack. If there are multiple of that, then it is a multiple rack. So when you store the data, we store the data in a way that the data is split also. In order to have a reliability, we split the data into different racks. If the data needs to be more reliable, we split the data into different cluster zone. One may be here, let's say you have 5 libraries of Seneca. One data will be stored in here, one data will be another library, third data will be third library, right? So that in case one library is down, it can be picked from the other source system. Okay. So that is nothing but a cluster. Only thing is when you split the data in the same rack. Okay. So if you have the data split in the same rack, retrieval is very quick because everything has to be picked up from the same rack, right? Its network delay is lower. But if you split the data into different racks, the slowness increases because the data has to be picked from this rack, then this rack. It will take time, right? For the network standpoint. If the data is split across the different countries in different cluster, delay is more. Okay, depending upon the configuration, how you want to store this data in a split format, it's totally the business organization need. Okay, do they want the data on the same rack, same cluster, same zone, same country? It depends. Okay. Basic concept is distance between the two nodes is equal to the sum of the distance to the closest common ancestor. Basically, the closer the nodes or the rack, the faster is the time to retrieve. The farther the nodes clusters, the increase in the time to retrieve. This is single node cluster. This is your lab. Single node is your lab. You have name node and data node sitting on the same machine. Right? Multi-node cluster means data node is sitting on different clusters or different virtual machines. Okay? Anything you want to read from here? Anything you want to ask?
In the first point, what exactly does the word daemons mean?
Daemons mean a process, job. You right click on your Windows Task Manager, you see the process name. Daemon is a process. This is running on. So when you run a Hadoop HDFS, start HDFS, you write it, right? Basically, what does it do? It start a daemon process, right? So you do start all CMD, right? Something like that. Start all CMD. It will start both name node, data node, yarn all together. So you have 3 processes running. If you start one by one, start data node, start name node. So one by one, it will pick it up.
There's a start.
Okay. HDFS communicates on a protocol that works on TCP/IP protocol. The client establishes a connection with the namespace using the configuration port. Default port is, I think, what is the default port when you configured? I don't remember the number. 9672, something like that, right? Default port for Hadoop.
9780.
9780, right? Okay. This is important. I will explain you. This is called as how to read the file from Hadoop file system. Please see here. It's an important concept you need to know. This will be used. So how the file is read from Hadoop file system is, let's suppose HDFS client wants to read the file from HDFS. I want to read a file data from the Hadoop file system. What is the first step? First step is, first the client will open the file by giving a call open method. Again, you are not going to write this, okay? These are inbuilt library functions. You can use it to program it. So first step is call open method on the file system object, which for HDFS is an instance of distributed file system. The first step is whenever the file read process is initiated, the call goes for opening a file. The method is open. Okay. Open call goes to the HDFS file system. Second step is distributed file system calls the name node using RPC. The next step is this file system calls the name node. Right? This. So let's say I want to read a file. I just send a message to open a connection. So somebody comes to your home. Think about somebody comes to your home to pick up one particular TV from your home. Okay, I came to your home to pick up the TV. I knocked the door. You open the door. Will you allow me to go and pick up the TV and go?
No.
No. Why? What will you going to ask me?
Why I did?
Am I authorized to see it or view it or pick it up, right? Isn't it? The first method is open the connection. So a client requests to get the data, it requests for open connection. Open sends the distributed file system, sends using RPC called as remote procedure call to determine the location of the block of first few blocks of the file. So it determines whether that even data is existing or not. First it has to check, right? After opening the connection. For each of the block in the name node returns the address of the data node that a copy of the block is there. Once the open connection is sent and the request for the data is initiated, remote procedure call. How many of you know remote procedure call? I have another 10 minutes faster, guys. What is RPC? Remote procedure call. How many of you studied C and C++, guys?
Long time ago.
Java. You studied, right? Did you study call by argument and call by value?
Yeah.
What is the difference between that? Come on, guys, you people didn't study data.
Argument is like what we pass to a function.
Yes, both are passed by function. What was the difference? If I say public static void main and you write a main function and you write an add function in that, you pass integer a comma integer b, and the function explain where you write add integer a comma integer x comma integer y, and then you write a like c is equal to x plus y. I'm just giving you. What are you passing from the top to bottom? Are you passing the value or are you passing the address? Address of the location, right? That is call by argument or call by address. The other method was call by value, where you actually pass the value. Here, that is remote procedure call. When the function is called remotely, it's called a remote procedure call. Guys, you need to study here. I studied 20 years back, guys. If you people don't study, 25 years back, not 25 years. 20 years, 22 years back. How can I remember? You people can't remember. I don't do programming anymore for last 10, 20 years. 15 years I've not done a programming. So each of the block of the name node returns the address of the data, the copy of the block, address where the data is stored, and the copy of the block where it resides. The client will interact with the respective data node to read the file name node and provide the token of the client which shows the data node is authenticated. So if I come to your home and I say, where is the safe of your jewelry? Will you tell me?
Yeah.
You will not tell me. The first thing, come on, yeah. You will tell me. So first step is, the method is I want your safe information. You give me the address. You are not giving it to the client the address. You are only telling where the safe is, where the information is, what is the location to the distributed file system. Distributed file system will read the input stream in the data node, figure it out where it is stored, but it will not give it the data back to the client. When it will give? Once the data node name node where it is. Once the token to the client which shows the data node is of authentication. Once it is authenticated, then only the data will be allowed to be retrieved. Okay. Once the authentication is established, when the token is approved or accepted, the data can be read from all these data nodes. Remember, when the data read is happening, okay, when the data read is happening, in between what may happen? Network connection may be broken down. Right, it can happen, right? Your data node goes down suddenly while you're reading the data. What happens? There is a process of acknowledgement. As and when the data is read, an acknowledgement is sent back, yes, we have read up to this, we have read up to this, we have read up to this, right? Any point of the time when the read is broken or data read is suspended, it is picked from the other data node. Okay, when the read process is completed, acknowledgement is sent back that entire file has been read or the entire data has been read, the connection is closed. Clear? That is very tiring. Writing a file. Okay, I will explain directly with the diagram. You people study the remaining one. How the write happens is now, first you are reading the data. Now I am writing the data into the Hadoop distributed file system. The simple process you did on your assignment was you just do put, right? It just simply write it. You don't know how did it write it. The process of writing is, first you will create a connection. You don't see this because you are running on your single machine. It gets window authenticated on your own user ID and password. But when you do it, the big organization, when you create a connection, Hadoop distributed file system will create a connection with the name node, whether you are even allowed to write it or not. That needs to be verified, right? Are you authorized and authenticated to write that data into the data node? First process is this. Once you have that authentication, you will send the FS data output stream, means writing method. This is a function, FS data output stream. You send the file data to be written, the method FS data output stream will start writing the packet to the different data node based on the split. It may write into the multiple data node at the same time. It can write it in one and then make a copy of the other. There are 2-3 mechanisms to write it. Okay, either you can write a packet in one. Once it is done, you want to replicate, you send that yes, one packet, one data set replication has been done. Now do the same thing on other. Each and every packet is written and the acknowledgement is sent back. Once the entire file is written, the connection is closed. Okay. Any point of time connection breaks, it can happen, right? What will happen? Since the acknowledgement packet is there, it keeps the track to the place till the file has been written. Whatever is pending, you resume from there. You don't just start writing it again. Okay. Okay. There are some of the commands which you all will do or you will learn since you have a Hadoop installation done on your machine. Like mkdir is like a single similar to Microsoft DOS command. You know, put means putting a file in HDFS file system. Copy means copy from the local. Get means to retrieve it. Copy to local. Cat everyone knows, right? Yeah. MV means move. CP is copy. You can read all the commands and that's it for the today's class. Any questions? I try to complete it faster. Let me. People on the phone or Zoom link, you have any questions? Please ask it. Any questions, guys?
Lab 1. Doing have to submit in PDF or Word format?
Word is fine, PDF is fine. Better to put a word. Okay. Okay, I'm pausing the recording to the Zoom link and I'm stopping the recording, guys.
Yeah, I will kill this.
Word PDF, either is fine. Thank you everyone in the Zoom.